Okay, if you look at example 6, the challenge is actually finding the values of A and B. If you can find the values of A and B, finding the equation is following the steps like in example 2. Okay, so first of all, right, when I look at the information, the first piece of information will be the coordinate. So I have this idea. So once I have this idea, I can put it into the curve. So once I have this idea, I can put it into the curve. And it actually gives you one equation. So some students, they can see this, okay? But some students, they will forget, they forget the X and Y idea. Okay, another one will be the gradient. So the gradient means dy dx. So they say that dy dx is actually equal to 4 when x is equal to -1. So you got to link the gradient of the curve to dy dx. So you must be able to understand that when you put x equal to -1, dy dx is equal to dy dx is equal to 4. But do you realize in this case, your dy dx may not be so direct because there is an unknown, right? So sometimes when there is an unknown, your differentiation might be a bit more difficult. And there's a bit of indices here. So I will need to do a little bit of indices. Then I can do my bring down power minus power. So of course, it also requires that you do your dy dx correctly. So I'm going to put in the information. So I will get this equal to a 4. So all in all, this is what you will be getting. So if you solve your A and B, you go and solve. Okay, I'm not doing the solving, obviously. If you solve 1 and 2, if no careless mistake, you will be getting A equal to, okay, what did I get? -1. And my B turns out to be a -6. Okay, so that will be the challenging part. If let's say you got careless mistake in your A and B, then the subsequent part here, when you try to return to do the equation of normal, you will find that your equation of course will not be correct. So it's a lot of chain effect in this sense. Okay, so I'm going to leave it to you. You go and try the equation of normal, see whether you can get the stated answer. Okay, so question 7 is a bit more difficult. It's one of those, example 7. It's one of those questions. Most people can do part A, they couldn't do part B. Okay, so I'm going to visualize it for you first. So, okay, there is a curve here. Okay, and then this is the point A. I only get the X coordinate. I don't have the Y. So this is the tangent. Okay, so part A is actually quite simple. We only want the gradient of tangent at X equal to 1. They didn't even want the equation of tangent. Okay, look carefully. They only want the gradient of tangent. And the gradient of tangent is in terms of K. Okay, so I'm going to get the curve and do my differentiation. That means I do not need to perform the full equation of tangent. So I just perform my first step, getting a dy dx. And then my second step, I substitute in the x equal to 1. So that will be the gradient of tangent. So this gradient is going to be 4 minus k. Okay, the next one. Okay, the next one you got to read carefully. Some students got a different interpretation. The tangent passes through this point. So some students, right, they interpret the point B to be on the curve. B is not on the curve. B is on the tangent. So B is on the tangent. So in fact, I'm going to try to use the chord jog gradient. So since this is a pair of coordinates, I'm trying to engage the chord jog gradient formula. So in order to do that, I need the full coordinate of x. So I'm going to work out the full coordinate of, the full coordinates of A. So I'm going to work out the full coordinate of A first. So I will get a 5 minus k. So A is actually this, and B is given to be this. So this is the A and B are on the tangent. So naturally, if I calculate the gradient, okay, so like y1 minus y2, okay, I don't like negative in the denominator, so usually I'll chip it up. So that will be the gradient. So when I use the formula, I'm given this gradient. When I use dy dx, I'm getting this gradient. But if you visualize, right, they are exactly the same line. So the gradient for dy dx and the gradient from the chord jog formula should be the same. So you cross multiply. Okay, so it will be quite easy for you to find the answer. You'll be able to find k equal to 4. Okay, so this is one of the few questions where we relate gradient from dy dx and also relate gradient from the chord jog formula. Okay, so there's still quite a lot of questions that you can be trying. But a big bulk of it deal with dy dx being the gradient of tangent or the gradient of the curve and some amount of chord jog. So there are even some questions that deals with area. So you can be using shoelace method, which is what you did in chord jog.